Have you ever wondered what holds atoms together in a molecule? Well, the answer lies in the fascinating world of chemical bonds. Chemical bonds are what keep atoms connected, forming the molecules that make up everything around us, from the air we breathe to the water we drink. There are four main types of chemical bonds that we'll be exploring: ionic, covalent, metallic, and hydrogen bonds. Each of these bonds is unique in its own way and plays a crucial role in the structure and properties of substances. Ionic bonds, for instance, involve the transfer of electrons from one atom to another. Covalent bonds, on the other hand, involve atoms sharing electrons. Metallic bonds are all about the attraction between positively charged metal ions and the delocalized electrons that surround them. And lastly, hydrogen bonds are a weak but important type of bond that forms between a hydrogen atom and a highly electronegative atom. So, are you ready to dive into the world of chemical bonds? First off, let's talk about ionic bonds. Picture a ballroom dance, but instead of dancers, we have atoms. In this dance, one atom, let's say sodium, willingly gives up an electron to another atom, like chlorine. This act turns sodium into a positively charged ion and chlorine into a negatively charged one. This isn't just a simple exchange though. The magic happens when these oppositely charged ions are drawn to each other, and voila, an ionic bond is formed. Now, why is this interesting? Well, ionic bonds are the Hercules of chemical bonds. Their strength ranges from 400 to 4,000 kilojoules per mole, making them the strongest type of chemical bond. Think of table salt or sodium chloride, NaCl. It's a common example of an ionic compound, and it's all thanks to this powerful bond. And that's ionic bonds for you, the strongest of the lot. Next up, we have covalent and metallic bonds. Covalent bonds are like the ultimate friendship in the atomic world. They form when two atoms decide to share one or more pairs of electrons. This sharing creates an attractive force between the nuclei of both atoms, holding them together. Now, the strength of this bond depends on the number of shared electron pairs. Single bonds are the weakest, double bonds are stronger, and triple bonds are like the superheroes of covalent bonds. Moving on, let's talk about metallic bonds. Picture a sea of delocalized electrons swirling around positively charged metal ions. This is the basis of metallic bonding. These free electrons moving around give metals their characteristic properties. Think conductivity and malleability. Metallic bonds are no pushovers either. They're fairly strong, and that's how covalent and metallic bonds work. Last but not least, we have hydrogen bonds. These bonds are quite special, forming between a hydrogen atom that's already covalently bonded to a powerfully electronegative atom, such as oxygen, nitrogen, or fluorine, and a lone pair of electrons on another highly electronegative atom. These bonds are weaker than covalent bonds, but they still pack more of a punch than the van der Waals forces that exist between non-polar molecules. Hydrogen bond strengths typically range from 10 to 50 kilojoules per mole. Take water, for instance, a substance we're all familiar with. In a water molecule, hydrogen bonds form between the hydrogen atoms and the lone pairs of electrons on the oxygen atoms. This gives water its unique properties. So, there you have it. A quick tour of the fascinating world of chemical bonds. Remember, it's all about the way atoms share or transfer electrons.